Hello, my name is David Mahalik. I'm an engineer here at Fort Defiance Industries. Today we're talking about the P2131 sterilizer, and what we're going to do is we're going to walk around the sterilizer with all the panels off and talk about each component. What does the component do? Why is it there? What does it do for the performance of the sterilizer? So right now we're on the left side panel of the sterilizer. You can follow along in the technical manual in section 4, kind of towards the back. So starting in the bottom left, we have the liquid level switch. What this does is it has a little float that is activated when you fill the jacket up with water. This liquid level switch tells the PLC whether there's water or not. If there's water, the PLC will operate as normal, turn on the heaters. If the jacket gets empty of water, it will not turn the heaters on. So this is going to protect you from overheating. Right here we got the vacuum valve. So anytime that the sterilizer evacuates the chamber, pulls out the steam, pulls out the air, this valve opens and the water recovery system pulls a vacuum through this side and all the air and steam is pulled out of the chamber. So this is a solenoid valve, just like all the other ASCO valves throughout the sterilizer. And so power is applied here. This runs back into the electrical enclosure. So right here we have the HEPA filter. This is to allow, whenever there's a vacuum on the chamber and you want to open the chamber door, you can't allow dirty air to go over the instruments. So air is drawn through the HEPA filter. You know, it's cleaned, all the dirty stuff has gotten out, to break the vacuum on the chamber so you can open the chamber door. These two valves are what open when you need to do that. So whenever you press vent on the PLC, these two valves are activated. Again, they're the same solenoid valves as the vacuum valve. The reason we have two is because this one holds vacuum. Whenever there's a vacuum on the chamber, this valve is working. Whenever there's pressure on the chamber, this valve is working. The unit just turned on. We're running a cycle right now, so it'll be a little noisy. But again, it's just running a cycle as we walk through and talk. So again, these are the vacuum brake valves, and very important which direction they go. There's a flow arrow on them, and the arrows should be facing each other. There's also a 1 and 2. So this valve, there's a 1 and 2, and on this valve, there's 1 and 2. So whenever you do maintenance on these, you're going to want to make sure you install them with the flowing arrows facing each other. So the vacuum brake valves. So up here we have two pressure transmitters. This is the jacket pressure transmitter, and what it's doing is it's reading the pressure in the jacket and sending the signal to the PLC so the PLC knows how much pressure is in the jacket. There's a little copper gasket that seals this fitting right here, and whenever you do maintenance on these, you're going to want to make sure that copper gasket is sealed and seated fully before you tighten down there. This one is the chamber pressure transmitter, has that same copper gasket right there. And these are actually the same transmitters, so when we send you a replacement part, it'll look identical. It also sends its signal to the PLC, so the PLC knows how much pressure is in the chamber. Over towards the back, we have the STERILIZE valve. So anytime that steam is jumped from the jacket through this valve down into the chamber, this valve opens. It's a solenoid valve just like the rest of them. So during exposure, this valve is open. During the conditioning phase, when you are doing a steam flush, this valve is open. Anytime you're doing a steam pulse, this valve is open. So this valve, very important to the operation of the sterilizer. Also very important for vacuum leak tests. This valve is very suspect if you possibly have a vacuum leak. So that's it for the top of the sterilizer, and we'll move around to the front and talk about it. So on the front of the sterilizer, with this bottom panel removed, very important part to the sterilizer operation is the drain manifold here. So this is mounted to the bottom of the chamber. So if you open up the door and you peek into that hole, you're peeking into this manifold right here. We got three things attached to it. This hose in the back is the vacuum exhaust hose. So anytime you're evacuating the chamber of steam or air, the water recovery system is pulling that vacuum and it's being evacuated through this hose. Right here we have the condensate hose. It has a red tag. As condensation forms and drips down in the chamber through the drain, it drips down to the water recovery system through this. That's why we kind of have that angle there, so the condensation will drip down there with gravity. Finally, we have the RTD probe. So if I were to slide this insulation out of the way, I would see some 1/2-inch swage lock tubing there. And if I were to remove the nut right here, I could pull out the probe. The probe has two elements in the end. The reason we got two is it controls off element 1. So as the sterilizer is running and holding temperature, it's reading off of 1. The second element is for a double check. So the second element is always checking up on 1 to ensure that it's reading the correct temperature, that it's not damaged. That way you know that the chamber is at the correct temperature during your exposure and you're killing all your bacteria. To replace this, we have a procedure, but you kind of pull this large insulation this way and you'll see a swage lock nut that you can break and pull out the whole probe. And that's it for the front. Alright, now we're going to talk about the components under the right side panel. Again, this sterilizer is running, so we're going to be very careful as we point and walk through this electrical box. We do have high voltage on the right, so if you ever were performing maintenance where the sterilizer had to be on, you'd have to be very careful on this side. It would only need to be performed by trained personnel. So I'm going to start from the bottom and kind of work my way around. So right here on the left we have the PLC. This is the brains of the unit that controls all the valves, reads the temperature, reads the pressure. It's what the user interacts with on the front with the touch screen. So you'll see that we have some input wires coming here. We also have some output wires coming here. And then we have the temperature coming in right here. So that's the PLC. Right here we have a buzzer alarm. So anytime you hear this unit beep, whether it's 1 time or 3 times, that's coming from the buzzer alarm right here at the bottom. Right here we have the DC power supply. So on the left we have 120 volts coming in, and on the right we have 24 volts coming out. So this power supply is what supplies power to the PLC, to the transmitters. Anything that needs 24 volts is coming from this power supply. Right here we have fuse block number 2. So these all use the same fuse. It's a replacement part in your manual. And these first 2 right here are 120 volts and the rest are 24 volts. So that's fuse block number 2. Right here in the back, it's kind of hard to see. We have terminal block number 2. So you'll see we have a lot of 120 volts. Across the bottom we have some of the neutrals, some of the grounds. But that is fuse block number 2 right there. Sorry, that's terminal block number 2. Right here we have the RTD modules or RTD transmitters. There's a number 1 and number 2. Again, the number 1 is correlated to the number 1 element in the RTD probe. That's what the sterilizer is controlling off of. Number 2 is constantly checking it. So during a cycle, during exposure, number 2 is checking up on 1 and making sure it's reading the correct temperature. These transmitters right here are very important. Here on the input side, we have an analog input coming from the RTD probes. On the output side, it's a digital Modbus output that is sent to the PLC. So these are very important for reading temperature and very easy to change out. Just removing a couple screws. Very important for your temperature readings. Again, this is the cable coming from your RTD probe. You have a little cord grip here just to keep it nice and tight. So if anybody's messing with it, it won't come loose from the transmitters. Alright, right here we have the contactor. The label says contactor C1. So on the right side, I have incoming power. And on the left side, I have power that's going to the rest of the unit. Right here, this white and purple wire actually go to the on and off switch. So when you turn that switch on, that is actually what is mechanically moving this contactor and supplying power to the sterilizer. So that's the contactor. Whenever you hear that click when you first turn the sterilizer on, that's this contactor moving. Right here, I have the wires to the heater elements. It's these three white wires. And if you follow them up, they go to those relays, which we'll talk about here in a second. But this goes down to the back to the heater elements, which sit in the jacket to provide the heat to heat up the water and turn it into steam. So those are the wires to the heater elements. Right here, I have a cable that goes down to the water recovery system. So you can follow those over. They connect to the terminal boards. This allows the sterilizer main unit to turn on and off the water recovery system. So all power for the water recovery system is actually coming from the sterilizer main unit through that cable. Finally, on the cables, I have this large cable, which is the input power to the sterilizer main unit. So again, it's 3-phase 208, very high voltage in this area. You want to be very careful. Also have a ground and a neutral, so it's a 5-wire incoming power. Right here on the side we have the cooling fan. This draws air across all the electronics and actually blows it out the back to keep all the electronics cool during operation. So very good check. You can kind of put your hand there just to make sure air is blowing. The power for it comes down this cable and connects to the contactor. So right when you turn that on and off switch, it also sends power to the fan. Right here we have terminal block number 3, which is just to connect the neutral and the ground, the green wire. So that is terminal block number 3. Right here we have fuse block number 1. So these are 30 amp slow blow fuses. They're all the same. And so this is for all the, there's one fuse per phase of 208 coming in. So we got 3 of those. Those just kind of lock in and out and kind of pry them out. But again, remember never to touch this area if the unit's on. All that maintenance has to be done with the sterilizer off and power disconnected. Right here, these 3 relays, very important relays here. We got 3 because each one corresponds to a heater element. So those, remember I was talking about the heater element wires down here. Those connect to the top of those 3 relays. And you can see those LEDs that were just blinking. Those are blinking because every time the PLC says to turn on the heater elements, it's supplying 24 volts across the bottom through this gray wire. And it's firing those relays, which is connecting the circuit across the top and allowing power to flow down to the heater elements. You'll notice they're mounted on pretty big heat sinks. That's to keep them cool during operation because they're firing very often, and that allows them to stay cool and not overheat. So again, that applies to solid state relay 6, excuse me, 6, 7, and 8. Now the rest of the relays over here, still solid state relays, but they are a little they fire a lot less than those three, so they're not mounted on heat sinks. You'll notice they still are connected to the PLC through the wires on the bottom. So this brown, red, yellow, blue, and purple wire, those are connected to the output of the PLC. So anytime the PLC says to fire any one of these valves, it'll send 24 volts to the bottom of the relay. It'll complete the circuit across the top and send 120 volts to, say, the STERILIZE valve, which is solid state relay 1, the vacuum valve, which is solid state relay 2, the water recovery system power. This is a little unique. Remember I mentioned that the sterilizer main unit supplies power to the water recovery system. That water recovery system power, it's always sending power down there. So when this unit is on, that's actually live, so that when you press the toggle switch to send water up to the sterilizer main unit, when you press that button, you can go ahead and operate the pump and pump water up to the sterilizer main unit. The vacuum brake valve, again, is on the other side that we already talked about. So whenever the cycle dictates to open that valve, the PLC will send 24 volts to that solid state relay. Finally, the water recovery system control. This is for during a cycle when the sterilizer needs to turn the water recovery system on. It will send power to this relay, which will turn the water recovery system on during a cycle. So again, this one is always on for the toggle switch, and that one is on for during a cycle. Alright, up here to the left we have the door switch sensor. It's this yellow piece with that green LED light on. You'll see these two metal clad cables coming in. That's to protect the fiber optics inside, just to make it pretty durable. So you'll notice there's a pretty big bend there just to protect and not damage those fiber optics. And the wiring comes down and connects to the terminal board, which is then connected to the PLC. Right here we have terminal block number 1, and a lot of that is the 24 volts and a lot of the connections to the valves and the transmitters throughout the unit. Alright, so that's it for the right side of the sterilizer main unit.